We're covering ACT Science, Passage 6. This is a data passage. Our DRC approach, data means don't read, just do enough to briefly understand what's going on. The question will tell you what to do. R&R approach, for the questions, you're going to read the question, then reread, breaking it down step by step. We're doing the reread together. This looks like a fairly complicated chart, and it's my experience that if you spend a little more time with a complicated chart, the questions are easier. So it tells you in this paragraph, it explains nucleotides, and it says figure 1 is used to determine what each codon specifies, and it says the first nucleobase is in the center. Okay, so we have GUAC, which stands there. The different nucleotides are explained in the first paragraph. The second circle is the next one, and then third circle is the last. And it gives an example. It says, for example, UUG is one of 6 codons that specifies leucine. So we see leucine 2 places, and it says UUG has those arrows to point it out. We also have 5 others. UUA, for example, will be the second one, and then CUC. So I'm going to do all 6 of them. Question 35, which of the nucleobases can be the third nucleobase in codon for isoleucine? I'm not sure I'm saying that correctly, but that's how I'm saying it. So isoleucine we see here, and which can be the third base. So we have the third base is the outer ring, so it can be A, C, and U only, right? Remember, the first is the inner circle, second is the middle circle, and the third base is the outer circle. So A, C, U, C. Number 36, we have a supposed question. We have to think a little bit. An mRNA strand contains 4 codons with this sequence. Which amino acid sequence will be specified immediately after methionine? I guess I said that correct in the strand. So assume you read it from left to right. So we're going to go left to right. So we're going to find first, methionine is here, right? And we could look in that pathway. It would be AUG, and we could see that in there. We could start from the beginning. GCU, we see GCU is alanine. Then we have AUG, well, there's methionine. Which one comes immediately after this? GCU, or now we're back to alanine. So alanine becomes immediately after methionine. So your answer is F. Number 37, in a complementary sequence. This is new information. ACT usually puts new information in italics. They didn't here. Nucleobases are swapped so that A becomes U and C becomes G. For example, GAA is CUU. So we're swapping them. Given the information and figure 1, which of the sequence is a complementary sequence for asparagine? So we have asparagine there, and that is AAC or AAU, either of those two. So let's swap those. We get UUG or UUA, right? We swapped based on A becomes U, C becomes G, and which one of those is in our answer choices? UUA, so your answer is C. The codons that specify a stop share a common feature. This one tripped me up for a minute because I couldn't find stop, but there it is. Specify a stop. What common feature do they begin with? Well, they all begin with uracil, so F. You can process and eliminate the others if you need to. Multiple codons that specify the same amino acid are said to demonstrate redundancy, so that it says the same thing more than once. Which of the following pairs of codons demonstrates redundancy? So I'm just going to process of eliminate. So AAA and GGG are lysine and glucine. So those are not the same. So we have AGG and GUU, arginine and valine, not the same. CUA and UUA, those are both leucine. So those are redundant. They are the same. So C. Consider the entire outer circle in figure 1. Serine is specified by how many different codons? You gotta find serines. We have it there and there. And then we have AGC, AGU, that's 2, UCU, UCC, UCA, UCG, so total that is 6. So H. You want to double check your answers, CFCFCH. These are all IOD questions, so point at the information and find them. Have a good day.